Next is WAN protocols. We have understood LAN protocols, now we are on WAN protocols. The acronym WAN stands for Wide Area Network, and it's used to refer to networks spanning much larger areas than a LAN, and often includes circuits provided by a telecommunication carrier or a privately leased line. Protocols that can transmit across longer distances, measured in miles or kilometers, are used to build WAN. When we want to communicate in different locations, then we use wide area networks, or you can say WAN. So when we need to transmit across longer distances measured in miles and kilometers, then we use WAN technology or WAN protocol. Types of WAN protocols are X.25, frame relay, ISDN, and DSL. Let's go through these. First is X.25. The X.25 protocol was adopted as a standard by the Consultative Committee for International Telegraph and Telephone, the CCITT, which is a consultative committee for international telegraph and telephones and is a commonly used network protocol. The X.25 protocols allow computers on different public networks like compulsive TimeNet or TCP/IP networks to communicate through an intermediary computer at the network layer level. X.25's protocols correspond closely to the data link and physical layer protocols defined in the Open System Interconnection, or you can say the OSI, communication model. We have two kinds of communication models. First one is OSI, the OSI communication model, Open System Interconnection model, and second one is TCP/IP communication model. So here we are talking about the OSI communication model. We have multiple layers in the OSI model and in the TCP/IP model. To be exact, we have 7 layers in the OSI model and 4 layers in the TCP/IP model. So here we are talking about an OSI model, and we are talking about the data link layer and the physical layer. So X.25 protocol corresponds closely to the data link layer and the physical layer protocol defined in the OSI communication model. Next is frame relay. The frame relay is a scalable WAN solution that is often used as an alternative to a leased line when leased lines prove to be unaffordable. Then we use frame relay. With frame relay, you can have a single serial interface on a router connecting into multiple remote sites through virtual circuits. AT&T stopped offering frame relay in 2012, but said it would support existing customers until 2016. Next one is ISDN, the Integrated Services Digital Network. ISDN was the first telecommunications service designed specifically for digital data communication. ISDN was designed to run over the standard voice digital telephone system already in place. Consequently, ISDN conforms to specifications found in telecom's digital voice network. We use in-voice communications. In telephonic communication, we use ISDN protocol. However, it took so long for ISDN to be standardized that it was never fully deployed in the telecommunication networks it was intended for. Like you can see in the picture, we have multiple telephone lines, and they are connected with ISDN topology. Next is DSL, Digital Subscriber Line. DSL is a technology for bringing high bandwidth information to homes and small businesses over ordinary copper telephone lines. XDSL refers to a different variation of DSL such as ADSL, HDSL, and RADSL. DSL technology uses normal phone line technology to send digital signals to the DSL modem. One of the major advantages of DSL over cable modem is that the line is not shared to the central office. The slow connections are rarely associated with this segment of your connection. So because DSL lines are not shared to the central office, their bandwidth is high. Next is network devices. The devices that are used in building a network that you must know are a hub, a switch, a bridge, and a router. Computer networking devices are units that mediate data in a computer network and are also called network equipment. Units which are last receiver or generating data are called hosts or data terminal equipment. We are connected in a topology by using a wire or cable or by using Wi-Fi connection, so networks using a star topology require a central point for the devices to connect. Originally, this device was called a concentrator, since it's consolidated and the hub cable runs from all the network devices. The basic form of a concentrator is the hub. The hub is a hardware device that contains multiple independent ports that match the cable types of the network. Most common hubs interconnect category 3 or 5 twisted pair cables with RJ45 ends. although coax BNC and fiber optics BNC hubs also do exist. This type of connection is called one-to-many. When we are distributing one connection to multiple systems in that particular area, we have used or we are using a hub device. A hub device distributes one channel to many connections, like you can see in the picture. The multiple devices are connected with a hub and a single device from which it is catting. It is distributing in multiple forms to multiple computers. Next is switch. So switches are a special type of hub that offer an additional layer of intelligence to a basic physical layer repeater hub. A switch must be able to read the MAC address of each frame it receives. This information allows switches to repeat incoming data frames only to the computer or computers to which a frame is addressed. This speeds up the network and reduces congestion. Switches operate at both the physical link layer and the data link layer of the OSI model. The basic working of a switch is one-to-one connection. Here we are giving one input and getting one output. As you see in the hub, we are giving one input and getting multiple outputs. One-to-many connection, but a switch is one-to-one connection. A hub is broadcasting the message. For example, when we are connected to a hub and System A wants to connect with System C, then System A will broadcast the packet over all the systems that are connected to the hub. With a switch system, if A wants to communicate with System C, then only C will get that packet. The switch will not broadcast the packet. This is the main difference between hubs and switches. Next is a router, or router device. Routers are network devices used to extend or segment networks by forwarding packets from one logical network to another. Routers are most often used in large internet networks that the TCP/IP protocol suites and for connecting TCP/IP hosts and local area networks or LANs to the internet using dedicated leased lines. Routers work at the network layer of the OSI model for networking to move packets between networks using their logical addresses. Next is NICs, Network Interface Card Device. NIC is a hardware card installed in a computer so it can communicate on a network. The network adapter provides one or more ports for the network cable to connect to, and it transmits and receives data through the network cable. Every network computer must also have a network adapter driver, which controls a network adapter. Each network adapter driver is configured to run a certain type of network adapter. We have a network adapter in our networking devices which help to communicate, you can say. For that, we have multiple ports in our network device on our network interface device NIC. We have 65,535 ports to be exact, networking ports in our NIC. We will go over ports more in the later class. For now, this concludes the first class of Course 1. Thank you very much, and we'll see you in the next class.